Okay, so let's take a look at these and see how you did on them so far. If you didn't finish them all, that's fine. So for this first one here, we're solving the equation. When it says solve, that means we're trying to figure out what the value of the variable is. So we're going to end up with a variable equals a number or a number equals a variable. So what are we going to do first with this one? Perfect. We're going to add 3 to get rid of that subtracting 3. Then we have to make sure we do the exact same thing to the other side. Remember, we talked about these equations and how they were built, and when we're solving, what we're really trying to do is take them apart. So now we have 7x equals 35, and then divide by 7. Perfect. That's gone. We divide the other, so all we have left there is x. We divide the other side by 7 to get 5. So x equals 5. Now we talked about going back and putting that in here. If I put a 5 in here for x, 7 times 5 is 35, minus 3 is 32. So that does work out. So the 5 is the correct answer. Over here on the right side, number 2. What do we notice that's slightly different about that one? Yeah, the variable appears twice. Now, when the variable appears twice, there's 2 possibilities. Either they're both on the same side of the equal sign, which means we can just push them together and combine them to make one big pile of variables, if you want to think of it that way, which is not what's going on here. Here, they're on opposite sides of the equal sign. So if you're thinking of that balanced scale, they're on opposite sides of the scale, which means we can't just push them together. So we have to get rid of one of them. Generally, we will get rid of the smaller. Oops, go ahead.
Can you just subtract minus 3 from the 5?
Yeah, what we're actually doing is we're taking away 3x. We're taking 3x off of this side to make it go away, which will leave us with just the positive 6. But if we take 3x off of one side, we have to take 3x off the other side. Now, we can't take 3x away from a negative 8. We can only take it away from other x's, other things with the same name. So we take 3x from the 5x makes 2x. So what we have here now is 2x minus 8 equals 6. So we go to solve that. What would be our next step? Add 8 to both sides. We add 8 to take the negative 8 away, leaves us with 2x. We add 8 to the 6, gives us 14. And then we'll divide by 2 to get rid of the 2. X equals 7. And again, we could go back to the original problem and put 7 in everywhere we see an x. So 5 times 7 minus 8 equals 3 times 7 plus 6, and see if that works out. So 5 times 7 is 35, minus 8 is 27. Over here, 3 times 7 is 21, plus 6 is 27. We get the same number on both sides, which tells us that that is a correct answer, a correct value for our variable. Any questions on those first two? So there, the key word, the key command is solve. When you're asked to solve, you are trying to find the value of the variable. Now this next set of questions, 3 and 4 here, we are given the command simplify. When you're asked to simplify something, simplify means to make it simpler. It doesn't mean you're going to come down to a single answer. It means combine what you can combine. So the toughest part of many of the simplify problems is knowing where to stop. A lot of people want to keep going when they can't. But simplify also means combine as much as you can. If there are still 2 things you can combine, do it. So looking at number 3 here, this is 8x squared minus 7x plus 2 Yeah, my handwriting left something to be desired on that one. Minus 3x squared plus 5x minus 9. Now, I purposely did a subtraction problem here because I know subtraction, when you have the negatives in there, is a spot where people struggle. So we're starting out, we're going to work right to left, just like we would with a whole number. We have 2 minus a negative 9. Can anybody tell me before I convert that over what that should equal? We have 2 minus a negative 9 becomes 2 plus a positive 9, which is a positive 11. Remember, when we're subtracting, if you have negatives in there, always convert it to plus the opposite. So it's addition. Now here we have the negative 7 minus 5. Negative 7x minus 5x, technically. But negative 7 minus 5. Again, I am going to convert that into negative 7. The first number doesn't change. It's the second number. So instead of subtracting a positive 5, we're going to add a negative 5. So we have negative 7 and negative 5. So our answer is definitely negative 12. They're going the same direction, so we combine the values. 7 and 5 make 12. So a negative 12x. We keep that same place value. And then this final digit is easy. 8x squared minus 3x squared. 8 minus 3 is 5x squared. How many of you got that one? Just a little show of hands. So we're still struggling. How many of you that didn't get it right, was it the negatives that got you? Okay. That's usually where it comes in that one. Now the key is, at this point you have to stop here because none of these have the same place value, the same name. This is x squared. This is just x, and this is ones. It's kind of like having hundreds, tens, and ones. You can't combine those digits. Okay, the second one then, number 4 here, was 5 times 7x minus 2 minus 3 times 2x plus 8. Sorry for the rapid scrolling up and down there. So, we see parentheses, which should always draw us to do something here first. So our first set of parentheses, is there anything that can be done inside that set of parentheses? No. 7x minus 2, we cannot combine anything there. Is there anything that needs to be done to that set of parentheses? Times the 5. Perfect. We multiply the 5 by 7x. 5 times 7x is 35x. And then it is 5 times negative 2, which is negative 10. So now we've completed everything for that set of parentheses. We move on to the next one. Is there anything to do inside that set of parentheses? Say no. No. There isn't, because it's an x and a 1s. We can't combine those with addition. Is there anything that needs to be done to that set of parentheses? Multiply by, careful, negative 3. Very good. There's a negative 3 multiplying that set of parentheses. So negative 3 times 2x is negative 6x. And negative 3 times 8, negative 24. So now, are we done? No. What can we still do? We can combine 35x with negative 6x. 35 and negative 6 make 29. There you go. 29x. Then we have negative 10 and negative 24. Negative 34. Perfect. We have negative 10 and a negative 24. Now your calculators do negatives for you. The way you would enter that, like the 35 plus a negative 6, you do 35 plus, and then you have to hit, the key actually looks like this. So you have to use that for the negative. If you use the minus key, no, calculator will not do the x's. There are calculators that will do the x's, like a TI-89 and a TI-88, but they are like $160. It isn't worth it. Okay, anybody have 29x minus 34 for that one? My batting average isn't going so well this morning. Okay, let's look at the last one. Did everybody get a chance to get to the last one, or does anybody need a minute to finish it? You got to it? Okay. Well, let's take a look at it then. So the first thing we have to do is we have to replace the letters with the numbers that are given for them. So 5a is going to actually become 5 times 8. Very good. Minus 2 times the parentheses. 8c is going to become 8 times 5 minus 12 times 3. 12m becomes 12 times 3. Over 4d becomes 4 times 2. Now when we have something like this, remember that fraction bar means you have to do everything on top first, then everything on bottom, and then divide. I'm actually going to move this down so I have more room to work on it. There. So I'm going to start by doing everything on top. I'm going to rewrite it over here so I have room. On top, do I have any enclosing symbols? Yes. Do I have any inside those enclosing symbols? Inside the parentheses here. Do I have any other enclosing symbols? No. Any exponents? No. Multiplication or division? Yes, there's actually 2 of them, so I'm going to go left to right. 8 times 5 is 40. And then I will do the 12 times 3, which is 36. Now I still have to do the 40 minus 36, which is 4. Now I've reduced everything inside that set of parentheses to a single number, so I can take out the parentheses. What do I have to remember to put in here, though? Times, because that 2 is in front of the parentheses with no operation. It's 2 times what's in the parentheses. Now, any other enclosing symbols? No. Exponents? No. Multiplication or division? Yes. 5 times 8 is 40. Then we have the 2 times 4 is 8. So we're left with just the subtraction. 40 minus 8 is 32. So the top of this is 32. Then on bottom, all we have to do is multiply. 4 times 2 makes 8. So now we have done everything on top. We got 32. We've done everything on bottom. We have 8. And we need to divide. 32 divided by 8. There we go. Any questions? Anybody get that one? Okay, so we got a little bit of work to do this morning. The good news is we're not going to do a whole lot of new material today. The bad news is we're going to expand the material we know more into the negatives. Yeah. Yeah. Actually, if it's just the homework, just keep going with it. It'll say there's a penalty, and I'll just change that when I transfer the grade to Blackboard.
When do you transfer your grades?
I usually transfer them while you guys are taking the test. It gives me something to do. So tomorrow while you're taking the test, I'll transfer all the grades and everything will be updated on Blackboard. Then hopefully by Thursday I'll have the test graded and So you'll have a current Blackboard grade. The official grade book is the Blackboard grade book, so don't get too hung up on the My Math Lab grade book, because your tests and stuff won't show up in there, but your quizzes and homework will show up. The best thing to use that for is so you can check to see if you missed something. Okay. Let's take a look at more of these equations. So now there were 3 commands that we saw up here. The first command was the solve, which meant we're going to try to find out the value of a variable. Simplify, which meant we can combine everything that we can combine, but we're not going to get it down to a single number. So you got to know when to stop and when you can keep going. And then the last command was evaluate. Remember, evaluate means to give a value to. So we gave values to each of those variables, each of the letters we replaced with numbers, and then we did the order of operations to figure out what that was, what that value was. So there were 2 of these commands where we could basically get our answer to a single number. Evaluate was one of them, and solve, kind of, because a variable equals a number, but same type of thing. Your answer will be down to a single number. Simplify, of course, you cannot get to a single number in most cases. Just some little cute clues for when you're taking the test tomorrow of when you're reading the instructions, what is it asking for? If it says simplify, most likely not going to get a single number or a variable equals a number for your answer. So keep those in mind. Okay. So we've been working with these equations, something like this. How would we go about solving this? Perfect. Even though there's negatives in it, as we're going to proceed just like we normally would, we have to subtract the 4 to get rid of the 4. Leaves us with negative x here, and we have to subtract 4 from the other side as well. 46 minus 4 is 42. Now what do we have to do? Divide by a negative 7. Perfect. That negative 7 is now gone, leaves us with x. We divide the other side by negative 7. 42 divided by negative 7 is negative 6. So x equals negative 6. So tell me what to do on this one. Perfect. We subtract the 12. How do we know that we're going to subtract 12? Well, let's go back and review that a little bit. Remember, we find our equal sign and we identify which side of the equation has the variable. So we've got the 3x plus 12 over there is where the variable is. Then we have to get rid of all of the pieces that are keeping the variable from being alone. The variable is multiplied by 3 and 12 has been added to it. So you think of putting it together. Order of operations says you'd multiply by the 3 first and then add the 12. When we take it apart, you have to go in backwards order. Take off the last piece first. So that is why we got to subtract the 12 first, because it is the last piece that would have been put onto this when we were building it. So the 12 is gone. That leaves us with 3x over on the right side. On the other side, we have to subtract 12 as well. 6 minus 12 is negative 6. Very good. Think of that as 6 plus a negative 12. So you get positive 6 and a negative 12. Puts us on the negative side of things. Next, what do we do? Careful. Where's the variable? Here's the variable, right? So it's the numbers that are keeping the variable from being by itself that we have to get rid of. So we got to get rid of the 3, and it is multiplying the x, so we get rid of it by dividing. So over here, negative 6 divided by 3 is negative 2. Any questions? Try this one in your notes, see what you get. So our first step is to, we have to get rid of the 17. It's subtracted, so we're going to add it. Why do we get rid of the 17? Well, if we look at this, here's our equal sign, and the left side is where the variable is. And over there, what's keeping the variable from being alone is the 4 and the 17. If you look at what's done to the variable to build the equation, it would have been multiplied by 4, and then 17 would have been subtracted. So to take it apart, we're going to start off by doing the last piece first and working our way backwards. So we add 17 to get rid of subtracting 17. That leaves us with 4x. What is negative 13 plus 17? 4. Very good. Now what? Divide by 4. Makes the 4 go away. We just have x. We have to divide by 4 over here to give us 1. Now, as always, we can put that number back in for x and see if this makes this true. So if I put 1 in for x, sorry, 4 times 1 minus 17, and does that equal a negative 13? Well, 4 times 1 is 4, minus 17 is a negative 13. So yes, we get the same value on both sides of the equation. So the 1 is a correct answer.
So it says negative 17.
Yep.
Do we minus, does that mean then we minus the 13 from the 17?
Nope, the 17 was subtracted here. So to get rid of it, we had to add the 17. So, okay, well, what you got to see, there's negative 13 plus 17, right? So from 0, you got negative 13 and then plus 17, like that. So it ends up on the positive side, and they're going opposite directions, so it's the difference in their value. The difference between 13 and 17 is going to be a 4. You may have missed a 1 or something when you entered it. So on your calculator, you'd have just typed in a negative 13 using the negative key like that. Okay. Okay, let's look at another one. Try this one in your notes, see what you come up with. So what do we start out with here? Perfect. A lot of people look at this and say, oh, there's subtraction we have to add, but that's not true. What's been done to my variable here? Remember we talked a little bit about those ones that are there, but we don't see them and we don't write them? There are 2 of them that are very common. One of them is, like here, if I have a variable and it's just x, or like if we just have an inch, you don't say 1 inch, you just say an inch, right? Same here, you don't say 1x, you just say x. But the 1 really is there. So here, this is really 1y. The other one, by the way, is a power. If it's a power of 1, you don't write x to the first, you just write x. but it really is x to the first. We learned that when we were dealing with powers a little while ago. So anyway, what's been done to y here? The first thing that was done is it actually multiplied by a -1. And then the 7 was added because it's a positive 7. It's added. If it were subtracted or negative, the negative would have to be in front of it. That's one of the reasons why I say we don't like to do subtraction, because this looks like you're subtracting the variable from a number. And that kind of is what you're doing. The problem is we have no way of solving an equation where the variable is doing the action. To solve an equation, it's always the variable's just sitting there and the numbers are doing the actions on the variable. So we have to change that. Instead of 7 with y subtracted from it, it's 7 with y times a -1. So anyway, next. So the first thing we have to do to solve this is get rid of that 7. It's been added. It's a positive 7, so we're going to subtract 7. Make it go away. 12 minus 7 is 5, which equals -1y, or just -y if you want to leave it that way. Then our next step to solve this is divide by a -1, leaves us with y. 5 divided by -1 is -5. This one's a little tricky to double check. If you go back up here, 12 equals 7 minus, y is a -5, so it's minus a -5. So you have to remember our rules for negatives. 7 minus a -5 becomes 7 plus a +5, which is 12. So 12 equals 12. What do you think? Good stuff? Better than a sharp stick in the eye? A little bit? So far. Okay. Well, since we're working and having fun with these negatives, let's keep going to one of our other commands, which was evaluate. Remember, evaluate meant give a value to. So for this one, we're asked to evaluate this 7f minus 3c all over 2m. When f is 6, c is -2, and m is -3. So we're going to start out by replacing the value, or the variables with their value. So 7f becomes 7 times 6 minus 3 times a -2. Now, when I replace a variable with a negative value, I always put it in parentheses, just because that avoids some mistakes. And then on bottom, we have 2 times a -3. So 2m becomes 2 times -3. Now I'm going to pause. Everybody understand how I got here? Any questions on that? Okay. So now what do I need to do first? I need to do everything that's on top there first. Good. And the first thing up there is going to be the 7 times the 6, which is 42. What's next? Okay, there's 2 ways I can look at this. I can look at this as being subtracting a 3 times negative 2, which would be 42 minus a negative 6. Or I can look at it as negative 3 times negative 2, which is going to be a positive 6. Is there a difference between these two results? Absolutely none. No. 42 plus 6 is 48. 42 minus a negative 6 gets changed to 42 plus a positive 6, which is 48. So this is where I told you before, when you have this like this, you need to think of this as being minus a positive 3 times a negative 2, or you can think of it as being a negative 3 times a negative 2, which is a positive 6. The thing to avoid is just make sure you don't count that negative twice. If that's a negative 3, well then it's now plus here. Because technically what you're doing, if you treat that as a negative 3, is you're making this plus a negative 3. So it's negative 3 times, it's plus a negative 3 times negative 2, which is positive 6. So it's either a negative 3 or it's subtraction. It can't be both. So the top of that becomes 48. The bottom is 2 times negative 3, which is negative 6. Are we done? No, what do we have to do? Divide. 48 divided by negative 6? Negative 8. Good. Any questions? I'm going to have you guys try one. So we're going to do 9d minus m times 4p minus 7d minus n squared plus 6 f minus 2. 4 d equals 2, m equals a negative 5, p equals 7, n equals a negative 6, and f equals 2. So give that one a shot. See what you come up with. So I'm going to start out by putting in the numbers. So 9 times d becomes 9 times 2 minus m is negative 5. Notice I put that in parentheses so I didn't confuse the minus and the negative there. Times, parentheses, 4p becomes 4 times 7 minus 7d. Well, d is still the same, so that's 7 times 2. Minus n is negative 6, so negative 6 squared, plus 6 times f, so 6 times 2, minus 2. So now we look for enclosing symbols. Well, this parentheses here is just separating the negative 5, so there's nothing to do there. Our first real enclosing symbol is this parentheses here. There's its other end. Inside that parentheses, are there any other enclosing symbols? Yes, right here. Inside that parentheses, are there any other enclosing symbols? Well, kind of. This parentheses is not an enclosing symbol. It's just separating the negative 6. So we don't have to worry about that one. Any exponents? Yes, there is the squared. Now, when you enter this in your calculator, remember you actually do have to put the parentheses around the negative 6 to square it. So it becomes a positive 36. Now I've squared that. I don't need the parentheses anymore. So this is 7 times 2 minus 36 plus the 6 times 2 minus 2 on the end there. Now I'm still working inside that inner set of parentheses right here. What do I need to do next? The 7 times 2, which is 14. Now what? I'm still working inside the parentheses. All that's left is 14 minus 36. Positive 14 minus 36 is negative 22. Very good. Now I've reduced the parentheses to a single number, but I'm going to leave them in there because it's a negative that's inside there. So I use that negative, or the parentheses, to separate the negative. How many of you are still with me so far? That your answers, your process is matching up with mine so far? I've lost most of you already. So what I'm going to do is I'm going to pause here at this point, right here, and have you guys try to take it from there and see what you can do with it. Okay, let's see where we go from here. Now again, this parentheses is not counting as enclosing symbol. It's just separating the negative 5. So this set of parentheses here is really our only enclosing symbol left. Inside there, what do we have to do first? 4 times 7. 4 times 7 is 28. What's the next thing we have to do in there? Perfect. 6 times 2, which is, careful, 12. Then what? It's all addition and subtraction, right? Perfect. We have the 28 minus a negative 22, which becomes 28 plus a positive 22, which is 50. So we replace that 28 minus negative 22 with 50. So we still have 50 plus 12, which is 62. Now it's down to a single number in that parentheses, so I'm going to get rid of the parentheses. And it is being multiplied by that negative 5 up front. Now what? Now we can go back and do the 9 times 2, which is 18. And we have the negative 5 times 62. Now this is still a minus here. Negative 5 times 62 is a negative 310. $18 minus a negative 310 becomes 18 plus a positive 310. 18 minus a negative becomes plus a positive, which is 328. Minus 2 is 326. Did anybody get 326? No. Yeah? Sort of? Okay. Now I'm going to show you something here. Back up at the beginning. Once we get the numbers put in right here, our calculator actually does do a pretty good job of that. I'm going to move my calculator over here and we'll start entering it. All I'd have to do is 9 times 2 minus, I'll do parentheses, negative 5 times, parentheses, 4 times 7 minus, parentheses, I'm going to move over so I can see the other half. 4 times 7 minus, parentheses, negative 6, close parentheses, x squared, close the parentheses right here, plus 6 times 2. Did I do that? Oh, I did. You are correct. Sorry. Let me put those in here. There, I got them in there. Thank you. And I have to do that yet. There we go. So 7 times 2 minus the negative 6 squared. Thank you. Plus 6 times 2. Close parentheses, minus 2. Now we'll see if I did this right. Uh-oh. That's wrong. There we go. Got 326. So if you enter this carefully into your calculator does do all those sort of operations for you. But notice it is beneficial to put these parentheses in around your negatives just to make sure your calculator does work with them the correct way. Any questions? Okay, well, it is about that time, so let's go ahead and take our first break. It is 9:59, so we'll start up again at 10:09.